Dark matter is the great sculptor, the architect of our universe. My name is Frenk. I am the Ogden Professor of Fundamental Physics at Durham University, and I am the director of the Institute for Computational Cosmology. I became interested in the universe when I was a young boy. I grew up in Mexico. I went hiking, slept in a tent. I opened the tent, and there it was, the universe staring at me. There were millions of stars that I could almost reach with my hand. It was a most moving and profound experience, as a result of which I decided to go and find out why it was there and how did it work. And then one thing led to another. I became a physicist, and then eventually I became an astronomer, and then a cosmologist. I have been in Durham for 34 years, and I've loved every minute of it. I wouldn't change Durham for anything. I think it is the most beautiful city, and our university is a wonderful university that has supported me and my colleagues for many, many years. One of the most shocking discoveries in science of the last 20 years has been the realization that a universe is made of some really, really strange, puzzling stuff. So we now know that only about 5% of what the universe contains is ordinary matter. About 20% is also matter. It doesn't produce light of any sort, and it's called dark matter. And then the rest, 75% of our universe, is something we call dark energy. We understand very little of it, but we know it's causing our universe to expand at an ever-accelerating rate, faster and faster and faster. That is one of the shocks of 21st century science. We don't know what the dark matter is, but we know it's there. The stars in the Milky Way feel it, because without dark matter, the galaxy would not be in place. The stars in the Milky Way are going so fast that they would have already left the galaxy were they not bound or glued in by something we cannot see, and this is what we know as dark matter. One way we could try to tackle the question of what is the dark matter was through simulating the evolution of the whole universe in a computer. So I spent my life making virtual universes. We suspect, for many good reasons, that the dark matter is an elementary particle that was created very, very soon after our universe came into existence in the Big Bang. The dark matter is crucial because it's the architect of our universe. The gravity produced by the dark matter is responsible for everything we see around us, because over the 13.7 billion years that our universe has been around, the gravitational force of the dark matter has accumulated mass into clumps, which subsequently gave rise to the formation of galaxies and other cosmic structures. If we understand the dark matter, we will understand why the universe has galaxies, why it has stars, why it has planets, and eventually we may even understand why it has people like us. We have made amazing progress in trying to understand what a universe is made of and how it works. And yet, some fundamental questions remain completely open. We know that the universe began with a Big Bang, but we don't know what went bang. We don't know what was there before the Big Bang. We know that the dark matter is the main force that controls the evolution of our universe, and yet we still do not know what exactly is the dark matter. And then, as though these were not already big unknowns, we have very little clue of what the main energy in the universe, the so-called dark energy, that is causing our universe to expand faster and faster. We don't know really what it is. We don't know whether it requires us to change an entire concept of physics, or whether it will be some profound intrinsic property of the space-time in which we live. Open questions that are one of the greatest challenges in science in the 21st century. Personally, I think I've been extremely lucky to have been able to spend decades trying to figure out how the universe works. It's not always fun. Sometimes it's hard work. Sometimes things go wrong. Sometimes you make the wrong calculation. And yet, there is nothing more exhilarating than to be able to contemplate the universe and wonder how it works.